Okay, we're going to be covering a little basic electricity. Now, this is not an in-depth course on electricity. This is just to get familiar with some of the terms, the terminology, some symbols. We're going to kind of briefly explain a little bit about voltage, how to take voltage readings, amperage readings, resistance. These are things that will need to be taken, these measurements, to diagnose air conditioning systems. And again, we're going to cover some basic electrical symbols. And, as always, please use caution when working with electricity. If you're replacing a part, disconnect the electricity, use your meter to verify there is no electricity present, and then you can proceed with replacing of the parts. Now, you will have to do some diagnosing with live electricity, so, be careful. We're going to cover that stuff as well. And so electricity, you can consider it kind of like a water hose, the pipe being the wire, for example, and then the voltage, is the pressure applied to the electrons flowing through the wire. So voltage, we in our home we have like outlets that's going to operate toasters. For a refrigerator that uses low voltage, 120 volts, that's our typical house voltages, and blenders, just typical household little small appliances. Now, when you get into the bigger equipment, bigger appliances such as a dryer, you're going to need more pressure, so your voltage is going to be higher. So on a condensing unit, you're going to have 240 volts versus 120 volts from the house. So we'll need to make sure that you got proper voltage to the equipment. Current is measured in amps, and A is for amperage, or I is for intensity. Those would be the symbols. So the current would be compared to the size of the hose. So for example, the bigger the wire, the more amperage, the more current it can hold, it can carry. And resistance, that would be just like, for example, sand. If you had debris in the pipe that's slowing down the voltage pressure, that would be resistance. And we'll need to take resistance readings to determine whether a compressor windings are okay, whether they're open. We'll take resistance readings on the compressors to see if it's grounded to the casing. Resistance readings of contactor coils. So we're going to need to take a lot of these readings. Current, for example, if a compressor runs at 8 amps, if we're drawn more than 8 amps, then something is seizing that compressor. It's having a hard time turning. So we can tell whether that's happening or not with taking the current readings. Okay, and we're going to cover on this next slide just another little example. These are the electrons flowing through, and for example, the more you open this valve, the more pressure that you'll have going through the pipe. And just another little example of that. And again, the size of the pipe would determine the current, and if you had any rocks or anything inside the pipe, that would be considered a resistance. So just another little example. And then here we have a basic electrical circuit. So let's for example use 120 volts that you would use in the home. So here is where the black wire, which is the power leg, you have it coming and ending at a switch. This switch is called normally open, and there are switches that are normally closed, but this one is normally open. And then you have your neutral, which goes to each side of this light bulb or a motor, whatever this might be. We're going to just say a light bulb, for example. So you have the neutral going to each side. Okay, and then this one here is your ground, and that's for safety reasons. In case something gets shorted, you want to have a path of least resistance, so the electricity will flow to the ground instead of You'll still get shocked though if you touch it, but it tries to divert the majority of electricity to the ground. So the incoming power, if we close this switch, then we're going to apply voltage to actually both of these light bulbs. Okay, so the voltage is going to come, we close the switch, it comes to this light bulb and also comes down to this one. Okay, so if this one is open, we'll have voltage coming down to here. We close this switch, then just this light will come on. So this is single pole double throw switch, which means it's got two legs, two switches. So with this one, you can control two of the motors. With this one, you can control one. With both of these closed, then all three of these will be on. So that's a basic electrical circuit. And these are some basic electrical symbols that we'll be using in the field. And this is that ground that we just saw on the previous slide. Some of these we won't be using. This would be a symbol of a fuse. You could have a disconnect box that has fuses in it. Control board has a little fuse. This would be a symbol of a motor with an M in there, light bulb, transformer. We're going to be working a lot with transformers. So typically you're going to have 120 volts incoming on this side, and it steps it down to 24 volts on this side. So this you can call it a step down transformer. 120 volts on one side, 24 volts coming out of the other side. Again, here is our normally open switch. Resistor, we don't work much with that. That's more electronics. Capacitor we do work with. This is a symbol of a capacitor to run your motors. These are connected to your motors to help them run. And again, diodes, we don't work much with that. The next slide here. And here's that transformer on the previous slide. Again, 120 volts, or it can be 220 volts down to 120 volts. There's different transformers for different applications. And contact normally open. So what we mean by normally open is that without any power, without anything happening in the circuit, this is going to be naturally open. And then when power is applied, then it would close. And this is a normally closed switch. So again, just sitting there doing nothing, it's going to be closed until power is applied, and then at that point it would open. Pressure switches, we have these in condensers. This would be a symbol of a normally open. As you see, it's not connected. And then there's normally closed pressure switches. So these, for example, if you have a low pressure switch in the condenser outside, if the system loses freon, that low pressure switch is going to open because of the loss of freon. It's not applying pressure to keep it closed. So that will open, preventing the condenser from coming on and damaging the compressor. Same thing with the high pressure switch. If the condenser fan isn't running, that pressure is going to get sky high, and it will open a high pressure switch, shutting down the condenser as a protection. This is a temperature switch. This is, again, a rise in temperature would open. And this here, thermal overload, you're going to have these in your compressor, your fan motors. These protected against high temperatures or high amperages. If the motor is really super hot, this will open, disconnecting power, preventing that motor from coming on.